This series is going to be a comprehensive, chapter by chapter, by topic video on the European Baccalaureate, the S7 Physics curriculum. And this is how you can use the resource. So I'm going to be making videos on a 7-part video, which I divided them into 7 chapters that I found um, useful and linked, right? And then each video, I'm going to link a Google Drive where you can access these resources, the lecture notes, as well as the past papers where you could practice. And in my opinion, these are the most effective way in the studying and using this guide. And firstly, it is by rewatching the video and resolving all the exercises that I'm going to put in the lecture notes, right? And then secondly, I want you to solve the past paper questions timed so that you can get a comprehensive overview on what to study and what these questions feel like in the actual exam. And lastly, I want you to make a definition sheet of the important definitions that I'm going to cover in the video. And you can do this by either rewatching the video or reading through the slides so that you can find what each definition and what each technical definition could mean in a scientific term. So who am I? Why am I making these videos? Am I even eligible to make these videos? And as I said, like in high school, it's kind of frustrating for me to study with the European Baccalaureate because there is no resources online. Like, okay, I think I saw the math video by I think one of the European school teachers who made series on European Baccalaureate math, but there's no other videos on, for example, physics, chemistry, or biology, right? So to my knowledge, this is the first video series on YouTube that should cover specifically the European Baccalaureate and not just random topics. And yeah, so I went to a type 2 European school, which is different to type 1 school, which is mostly located in, like, for example, Belgium and Luxembourg, I believe. Right? I went to a type 2 school, which is just uh, well, a different type of school where you do the European Baccalaureate, but like it's not funded, to my knowledge, it's not funded by the European Union, right? And it's just accredited so that it's been accredited by the European school people so that you can do these school can teach the European Baccalaureate, right? So I did my European Baccalaureate in a small town called Manosque in France, like southern France, and I finished the baccalaureate last year, 2025. And as you can see, school year 2024 to 2025 up here. And okay, the reason why I decided from all subjects to teach physics is because I had a perfect score on the written exam, which I got 100 out of 100. And I had a pretty decent GPA of around 95% in, well, the preliminary, I always can't pronounce the word, preliminary mark, right? I had around 95% GPA, and I had a final mark around 97%, which I believe is quite good. And in this video series, is not only gonna teach about the topics, but also the exam strategies and general ways to approach physics. So right now I'm studying nanoscience in the ISC division in Yonsei University, which, if fair enough, if you haven't heard of it, because it's a university in Korea, right? It's generally considered top 2, top 3 university in Korea. And uh, yeah, the reason why I went to Korea, well, I won't explain here, but it's because I'm South Korean. I was born there, but I did my education in France and Canada, and that's why I did my uh, European Baccalaureate in France, right? So I know this is a kind of a corny line to say, but I think this is really useful when it comes to exam strategy, right? The way you should think about exams. And maybe you heard of this, I think it's a Chinese war strategist or something, right? And his quote is that if you know the enemy and know yourself, you need not fear the result of 100 battles. So the reason why I put this quote is that, okay, if you know what you're weak in, your weakness is, and if you know what the exam covers, right, you can then, well, work on yourself, right, to become better in your weaknesses in order to take, hundreds of exams, right? So I think not only for European Baccalaureate, but for if you're taking, for example, SAT, AP, IB, or any types of external exams beside the European Baccalaureate, right? I think it's a useful mindset to have that if you know your weaknesses and your strengths, you should be able, well, you should be capable of, well, taking hundreds of these exams without fearing that you're going to get a bad result because you know the contents of the exam, right? So, going on this topic, let's learn about what the European Baccalaureate is actually graded on and what is this based on, because um, I think it's always good to know about what these are about, or what each exam covers, so that when you go in the exam, you're not surprised that there is this topic that it is graded on this factor, right? So this is actually like a screenshot from the official curriculum, like that you should be able to find online if you search up European Baccalaureate S7 Syllabus. If you search up that, you should be able to find like a PDF around, like, I think almost 100 pages, right? And this is just one screenshot from one of those pages. And okay, the European Baccalaureate covers 4 questions in the exam, and the exam itself is 3 hours, right? 180 minutes. So if you have 4 questions, it's 180 divided by 4. It's going to be little over, well, around 45 minutes per question, right? But realistically, if you want to double check afterwards, it's around 40 minutes per question. Some sections, in my opinion, are easier than other, which I'll get into later. And the first topic we're going to cover is fields. I'm going to get into more depth later, oscillation and waves, quantum physics, and mixed topics. So these are the big 4 topics that we're going to cover. And then this is the criteria that it is graded on. So knowledge and comprehension, application, writ analysis and evaluation. And this is, I guess, a big chunk, written communication, right? And in my opinion, European Baccalaureate is not only about solving equations and writing down definitions, it's also presenting a good paper. What do I mean by that? Presenting a good paper means it should be organized, it should be really easy for examiners to correct. My teacher always used to say, if an exam takes you, if the exam takes them 1 hour to correct, it means it's a really bad exam, right? But if the exam takes the teacher, let's say, 15 minutes to correct, that means it's a really good exam because it's the teacher aren't trying to decipher what the equation is, what your handwriting is. So um, we will focus on each of these later, right? And I think it's quite useful to know in general what the grading criteria are for any types of exam. So, okay, technically, European Baccalaureate is a 2-year syllabus, and it is kind of tested on your 2-year knowledge. But from your S6, the only topic that you kind of need to revise is fields, which is electric fields, magnetic fields, and gravitational fields. And then, actually, although you do not really have these topics explicitly written for periods in S7, you might be tested on them, especially on the gravitational field chapter, where you might cover, um, like rotations or like planetary motion. You might need to know these. And oscillation and waves. Okay, this is a big topic that we're going to cover in S7. And this is basically going to be standing waves and also interference phenomena. And realistically, right, only part that you need in S7 is going to be the notion of superposition phenomena, which I believe was covered in the behavior of waves. right? And and in oscillational waves, as I said, there will be standing waves and electromagnetic waves, which inside there is the interference phenomena, which is going to be the first chapter we're going to cover, but I'll delve into that a bit more later. So obviously you didn't cover quantum physics in S6. I mean, maybe some of you do, but in our school we never covered about quantum physics. And although as intimidating as it sounds, it's hopefully, I mean, it's not crazy difficult, right? They don't test you on the in-depth knowledge of quantum physics. It's just gonna be a brief, um, yeah, brief topic, right? Okay, so this is what the official exam says, right? Official, well, on the from the PDF, it says, okay, questions for the baccalaureate written paper are based on the physics syllabus in the seventh year, so S7. Although they may call knowledge acquired earlier, knowledge of material covered only in the optional section of the syllabus will not be assumed. So technically, right, you could be asked to basically provide some knowledge from S6, right? As I said, right? I think in one of the papers there was a question on is electromagnetic wave transverse or is it a longitudinal wave, right? And I think that's only covered in S6. It's not explicitly stated to cover in S7. So there could be some small questions where these knowledges are required, right? But I'm gonna try to do everything so that I can cover most of the knowledge that is going to be in S6 and S7, right? If you want, you can pause the video and read the rest of it. But mostly you're not going to need knowledge from S6 besides, as you can see, the overlapping ones here, right? And I guess a bit of circular motion, in my opinion, to my experience, right? So I split the European Baccalaureate into 7 chapters, as I mentioned, because firstly, it's the way that my teacher split it, and it was really I think it was really good the way he split the exam. So not the exam, but the syllabus. And furthermore, I think um, that going in this order helps you better understand each topic, in my opinion. So chapter one is going to be covering the interference phenomena, and this is the actual physics formula booklet, and this is the equations that we're going to be studying and deriving. These two up here. And also we'll be studying about the electromagnetic spectrum in this topic as well, because this knowledge is required to talk about the interference phenomena. And if you want, you can pause the video here, have a read at the official syllabus. It's here, right? And this is the electromagnetic wave part, right? And it just um this is a really easy part, right? For example, here, right? I put 3 out of 5 stars, right? I would say interference phenomena, I would say it's around 3 or 4 out of 5 stars, right? And difficulty, whereas the electromagnetic wave, you just have to like state some definitions, calculate how long is a frequency or wave given the other value, right? So it's fairly, I would say it's one of the most simple topics that we're going to cover. So, and you should have prerequisite knowledge from S6 or S5 on electromagnetic waves, so it should be quite simple. But I'm going to be covering all of these in comprehensive detail, so don't worry if you are not, if you aren't sure. So, second chapter is going to be standing waves, and this is a very simple chapter in my opinion. If you get this on the exam, this should be 3 points, right? And this is what we're going to be studying, the equations that we're going to be studying. But actually, like if you're looking at your formula sheet in order to find the equations, right? I think um it's already too late, in the exam if you're looking at the formula sheet and you're like, so yeah, I remember this was the equation for which one was it? If you're thinking that, you're already messed up. So um in my opinion, right? These formulas, you really don't need them because you're gonna be asked to derive them, I would say 80% of the time. So yeah, these are the equations we'll be studying. This is a very easy chapter. Yeah. And if you want, you can stop here, have a read at this, right? Just gonna be drawing some stuff, deriving some stuff, calculating some stuff. It's really not that hard. So chapter three, it's fields, and I would say this is a fairly complicated chapter because we'll be introducing a notion uh, called potential, which is different to potential energy, right? And I know it sounds confusing at first. Okay, what's the difference between potential energy, right? Well, I'll be explaining all of that in chapter three. And these are going to be the equations that we'll be covering. And here, as you can see, this is the gravitational formula, right? Gravitational field. This is going to be the electric field formula here. And this is a fairly big chapter, so I might split into two videos, but I'll see, right? And at first, it should be fairly simple because it's just going to be revision of S6, but it might get complicated towards the end. So I'll put this 4 out of 5 on difficulty as I put it here, right? And if you want, you can pause the video here, look at the curriculum, right? And okay, chapter 4. This is the Lorentz force, and technically in the syllabus, this is a subsection of field because Lorentz force is also um, basically uh, a force experienced by a charge in a magnetic field, right? So it's technically a subchapter of, I guess, field and magnetic field to be more specific, and these are going to be equations we'll be studying, but I just split this into a different chapter because firstly, it's fairly non-intuitive, and also I think since on the equation on the formula sheet, since it is, put it in a separate box compared to the gravitational one, I think it's better to learn it separately after learning about the gravitational potential, no, gravitational field chapter, basically. And if you want, you can pause here, have a look at it. And chapter 5, induction phenomena. And this is also a sub chapter of sub chapter of the fields chapter, right? Because induction, to be quick, it's something to do with magnetic fields. You don't have to know what it is right now because we're gonna obviously cover it, right? And it's not too easy, but like in the exam they're never gonna ask you too difficult things about it because still we are in high school curriculum, right? So I'm going to cover the depth that you're going to be required to know, right? So these are the two formulas, as you can see. I'm going to explain what each of these means in the coming chapters. So don't worry if you don't understand anything right now, right? And if you want, you can have a pause and have a read at it, but I don't know if it's useful actually, because you're not going to be comprehending much. So it would be useful maybe like in the later when you finish this course to actually come back on this video to pause at these parts to actually ask yourself, do I know each of these topics here, right? But I feel like in the later videos, I'm going to be doing that at the end of the video anyway. So yeah. So chapter 6 is going to be the part 1 of quantum physics, and it's hard, right? As I said before, that it's not too hard, right? But it is fairly difficult compared to the other chapters, right? And these are the equations we're going to be studying. And I would say for this chapter, the main difficulty comes from like trying to like visualize what each of these mean, right? It took me probably a couple days just to understand, for example, the photoelectric effect, the equation here, right? So it's just gonna be it is difficult, I would say, but um to my experience, they never ask you very, very difficult questions about the quantum physics part. It's just going to be mostly calculation, maybe definitions, right? So, although it's difficult, right? If you have a like a if you comprehend all the equations, I feel like you are good enough. But I feel like if you're aiming for maybe 90, 95, maybe even 100, right? I don't think this is just comprehending the equations are enough. So I'm gonna try to explain as best as possible, although I'm still, first year bachelor student, right, studying nanoscience, so I'm not qualified, I would say, to teach quantum physics, but I can teach quantum physics in a depth that I learned in high school. So, because to be fair, like I did score quite high on the exam, so I think I do have some authority over teaching, hopefully, right? Okay, and this is a syllabus, right? There's a lot of things that you're gonna have to cover, right? You might be overwhelmed. You're like, do I really have to know all this? And I think the reason why they wrote so many pages just for quantum physics is that they don't want the students to go too deep into, or the teachers to go too deep and confuse, get too deep into the topics, right? And they put the exact things that they have to know, right? They didn't make it ambiguous. They just said, right? Okay, these are, apply, describe, and compare these following things, right? So they didn't make it ambiguous so that you know what you have to know, right? And chapter 7 is going to be the part 2 of quantum physics because I don't want each weekly video to be 5 hours, 6 hours long, right? I want to keep them fairly manageable because uh, yeah, I mean, I don't know if I'll be able to edit a video that is 6 hours long, to be honest. So, we're going to be studying these following equations here. And if you took chemistry, if you are taking chemistry, right, you should be familiar maybe with this equation here, or yeah, this equation here, which is the hydrogen atom's energy level, right? So, if you took chemistry in S6, this chapter is going to be a little easier, but still it is quite difficult, right? Because you're gonna have to learn about Schrodinger's wave equation, etc. So I'll say 5 out of 5 difficulty, but they are never gonna ask too difficult things about two things that are too difficult about this chapter, right? For example, I remember during my baccalaureate, I remember being asked to describe each quantity in this equation here. What does the H stand for? What does N stand for? What does M stand for? What is L? Right? So it's fairly simple stuff that they're gonna ask, and I don't think it'll be very difficult. Right? And here again, they wrote a lot, but as I said, it's not because to scare the students, right? It's more to like make it certain what you have to know and what you don't really have to know, right? So about I showed you this screenshot already, but I'm showing you again, but with the chapter notes that I put, right? The way I split into chapters, right? So chapter 1, no, I mean not chapter 1. Chapter 3, 4, and 5, I put that with the fields chapter, right? So this is going to be gravitational electromagnetic field here, and then this one is going to be, I think, Lorentz force, and this one is going to be the induction phenomena, which we're going to study. And oscillation of waves, as I said, these are the two easiest chapters. So this is going to be interference phenomena, chapter 1. And chapter 2, it's going to be standing waves. And then question 3, it's going to be chapter 6 and 7, as I put. And mixed topics to explain briefly, right? For example, right? In question 1, you're tested on, let's say, um, generally, to my experience, it was the case that you're tested on like maybe like gravitational potential energy or like gravitational fields or electric fields, right? Question 2, you might be asked on maybe standing wave, right? And then question 3, you might be tested on, well, just quantum physics in general, right? Because these aren't technically separate chapters. It's just that I put them into separate chapters because I don't want them to be too long. And yeah, as you can see, the mixed topics are generally going to be the ones that aren't tested before, right? So for example, if chapter 3 was covered, maybe chapter 5 is going to be chapter 5, maybe chapter 1, and maybe a bit of quantum physics is going to be combined into the last question, right? But it's not always the case that they are combined, right? It might be the case that like they have maybe short questions, like maybe like on Q4, right? They have three sub questions on Q5 and then chapter 5. They have maybe two sub questions on chapter 1, and they have maybe just a very short definition for like maybe chapter 6 and 7, right? So it really depends on the year, right? Because I feel like European Baccalaureate, they change a lot every year, the exam paper. So you just have to be ready for anything, basically. And as I said, right, I told you before that written communication is essential when it comes to the European Baccalaureate, right? And from S6 to S7, my biggest transition was that I started writing everything very, very neatly. I fixed my handwriting, I fixed the way I presented my results, right? And I think that's one of the reasons that allowed me to get 100, right? And um, what my teacher always used to say. Well, he was very strict, right? My teacher, but he was also a very good teacher, in my opinion, right? And for example, um, one of the things that he mentioned is how you should answer each question, and he called this, he had a poster in his in the classroom, right? He called it 5 steps for success, and what I did was I actually printed this out and then I stuck it on the first page of my physics binder. So actually, these are the actual steps that he put, but I added step 0 because I think it is crucial, right? Number 1, right? Number 0, step 0, right? It's fundamental. Always read the question fully, right? What a lot of people make mistake doing in exam, and not only for European Baccalaureate, is that they're gonna look at a question and then they're gonna be like, oh, I solved this in the past paper, and they're going to be just trying to solve it from memory instead of actually trying to solve the question, right? And it is, like, I would say 99% of the case that, you know, the questions are slightly altered, right? So, for example, maybe they're going to be finding frequency instead of the wavelength, right? So, always read the question fully, right? Know what the question is asking for. And this relates with step 1, right? Write down what has to be calculated. So I put an example down here, right? For example, this is the question, right? Suppose that the slit separation is doubled. How will this affect the fringe separation? Justify your answer, right? This could be a answer, not a question in the exam. And firstly, you don't have to know any of the equations here because we're going to cover them, but I'm just showing you as an example, right? So this is the statement part, right? So I wrote the question P, right? And I wrote sub question 3, right? And the question, what is it asking? What happens if you double the slit separation, right? So I wrote effect of doubling the split separation S, right? So what I notice with a lot of people is that they're gonna be doing like some complicated calculation, blah blah blah, and then they're gonna stop. They're gonna be like, "What was I asked to find?" Right? And a lot of people have these moments, in my opinion, and that's why you should always write down so that you can have a look at your uh, statement and see you're like, oh yeah, I need to find the slit separation, or I need to find the distance, I need to find this, right? So that you can be sure yourself what the question is asking for and you're not trying to find some random value, but also you can make it clear to the examiner what you're doing in the question. So, and the second step is writing down the relevant formula or the relevant law, right? And for example, for instance here, right, one of the previous question was to derive the formula up here, right? And I wrote here that, okay, we found this statement up here. So this is a law or a formula that we're going to state, right? So when you're invoking, things that you have to know from the previous question, you always should write, okay, from this question, we found this equation, right? Otherwise, the examiner might be like, okay, like, did you pull this equation out of your head? How do you know, right? So always invoke, right? They said, we found this in question B, part 1, right? And then second step is a literal calculation, right? And this part means that you should answer the question using the given values, right? So for example, in this instance here, right? From this relation, you can derive that, okay, numerically, x is directly proportional to 1 over s. So from here, you can see that from this formula to down here, we can see that x, right, we can say numerically, since s is down here, we can say x is directly proportional to 1 over s, right? So this is going to be the literal calculation part. This is just going to be, for example, you have up here, for example, if you did Newton's law, right? This F is ma is going to be the law part, right? Newton's second law, right? And then maybe on the literal calculation part, you're going to derive that maybe tension minus gravity is going to be the mass times v squared over r, for instance, right? So this is going to be the literal calculation part where you're going to find the final answer using the given quantities, right? And what I want you to do is not to memorize all these steps, but practice it so many times that it becomes ingrained in your habits. And the literal calculation, and then it's going to be numerical application, right? And for example, here, right, we found that, for instance, x is inversely proportional to s, right? So what we could do is we could have done is plug in the numbers up here, but that's something you should never do, right? In physics, you should always find your formula first and then plug in your values. This is due to many reasons. One of them being that you're going to you're going to lose or gain significant figures. And it's going to be annoying every time. You're going to lose so much time just plugging in the values in the calculator. And second reason being that it is very, very confusing for the examiner to be like, okay, you found this here, you found that here. And then, the examiner is going to be confused and they might not actually give you the mark. And then step 5 is presenting with units, presenting the result with units. And for instance, this is gonna be in this case, effective doubling slit distance S will half the fringe separation, right? And not every question you're going to be have to write the units, right? For instance, this question, right? You're like, okay, justify your answer, what happens, right? So if it has, there is no units, right? If something divides by 2, right? But generally, for example, if you're asked to find maybe the height, you should always write down meters, right? If you're given to find the charge, you should write down coulombs, right? So always, always, always write down your units, right? For example, for my teacher, right, he never gave the point unless you wrote the unit, right? You could have done every calculation correct, and the final question, if you didn't write down your units, he gave you 0 points, right? So that's how you should treat yourself as well. If you don't write down the units, the examiner might not give you the full mark or not even any mark in the question. So I know it's unfair, but it's something you should get habit of doing. And uh yeah. So this is going to be it for the first series of this video, right? And the next video, we're going to be covering the chapter 1, right? We're going to be covering interference phenomena, and then we're going to be covering the electromagnetic waves. So see you in the next video.